The city of Rio de Janeiro will be one of the places most impacted by rising sea levels due to climate change. Around Guanabara Bay will be one of the hazard hit areas, as well as another neighborhood nearby.
In line with this, there is a wide population density, with a large part of need communities with little purchasing power, for example, coming from artisanal fishing in the north of the bay.
Other activities of greater relevance, such as the airports, contribute directly to the economy, since Rio de Janeiro is a tourist city.
Guanabara Bay was named after the Tamoios and indigenous people, as an area that corresponds to approximately 400 square kilometers and containing about 3 billion cubic meters of water. It is considered an estuary of 55 rivers coming from 16 municipalities, with flow on average more 200,000 liters of water per second by. However, most of these rivers have a road concentration sweat from several places with now basic sanitation. With dump effluent directly and however, and that even if parts of this water is treated is estuary north and comprises water quality of bay.
The Guanabara Bay ecosystem is quite heterogeneous, formed by estuaries, high-altitude fields, swamps, and mainly mangroves, with places considered environmental protection areas. Therefore, fauna and flora depends on its aquatic and coastal regions, having around 242 species of birds, 167 of fish, and 66 of terrestrial animals.
The President Costa Silva Bridge, known as the Rio Niterói Bridge, connects the two cities across the Guanabara Bay. Its flow of vehicles is intense due to the concentration of companies and servers in the center of Rio. To contain the advance of the sea in the region, it is necessary to establish mitigation measures.
In this map, an overview of the solutions is visualized. The biggest part of the solution will be a 9.5 kilometers long closure dam located near the Rio to Niterói bridge. With this solution, a huge area is saved from 3-meter sea level rise. 194.5 kilometers of quay improvement work is prevented with this solution. We choose to place it at the bridge and not at the mouth of the bay, so the commercial ships and navy will still be in direct reach of the ocean. Therefore, the port at the western side and the navy base isn't disadvantaged by the solution. Not closing at the mouth of the bay means there are still unprotected areas left. Since the time schedule of this project, a choice has been made to only focus on the area surrounded with the black line. A summary of the other solutions to protect the area is visible in the table on the right-hand side. A combination of these solutions will keep this area of Rio de Janeiro safe from a 3-meter sea level rise. The solutions will now be visualized and explained.
We start at the eastern side of the bay. Between Rio de Janeiro and Niterói, there will be a 9.5 km long closure dam, which will protect the bay from 3 meters of sea level rise. The closure dam will be 11.5 meters tall and 150 meters wide above water. It is possible to access the dam by car or by subway. In both directions there will be 3 lanes for cars and 1 for the subway. To protect the dam from erosion of the sea, the sloping side will be covered with basalt boulders to decrease the power of the waves.
In the dam there will be 2 sluices to make it possible for the ships to enter the bay. The 2 sluices have different measurements. The big sluice is 300 meters long and 60 meters wide. The smaller sluice is 200 meters long and 40 meters wide.
Through the fish passage, fish can swim to both ways of the dam even if the water levels are different on both sides. Throughout the length of the dam there are multiple fish passages, so the fish can easily get to the other side of the dam.
Here we see one of the 3 pumping stations, which are used to simulate the tide inside the bay to preserve the ecological quality. With a total pump capacity of 9,000 cubic meters per second, it is possible to raise or to lower the water level by 1 meter within 9 hours inside the bay. By letting the seawater flow into the bay, it's possible to generate energy.
To protect the porch in front of the dam against 3 meter sea level rise, the Q-walls in the porch need to be raised, so the economic value of the porch will not be damaged.
The mangrove forest in front of the shore will reduce the power of the waves and reduce the erosion of the coastline. The trees can survive in the sea and will break the waves. In between the forest there is place for recreation, for example, a walking track through the forest. Oyster beds will also be placed in front of the mangrove forest. The oyster beds form an underwater barrier, so the flow of the water and the power of the waves will be reduced. These 2 coastal defenses are a good example of building with nature.
With the installation of solar panels line in the dam, it's possible to generate more than 80 megawatt-hour per day. This energy equals to more than 14,000 houses of the region, or pump more than 2,000 cubic meters of bay water back to the sea. Depending on the traffic, a piezoelectric system could convert the vehicle's vibration in about 4,720 kilowatt-hour of energy.
With the closure of the Guanabara Bay by the dam, there will be a higher concentration of pollutants in the locality. Once the water renewal will be made in a mechanized and slower manner. To minimize impacts such as the eutrophication of the bay and the death of marine fauna, complementary solutions to the dam will be implemented. For the liquid effluents discharged, sewage treatment plants, license issuance, and environmental impact studies will be required. For flowing garbage, eco-barriers will be used in the rivers, implemented before the treatment stations. The residues discharged directly into the bay's water body will be collected by eco-boats in constant operation. This is the end of our project. Please like and subscribe. Thank you. It was made possible by Rotterdam University of Applied Sciences and University of Veiga de Almeida.